Well, I finally finished my chicken coop. This is the wintertime abode. We have the chicken tractor for the summertime, but we really needed something for the wintertime, and this is what this is about. It's been nicknamed the Taj MaCoop. You know, it doesn't have reflecting pools and marble and tile, but it kind of makes up for that with other features. In fact, I'm going to go through each one of these. Now, I'll talk about them a little bit later more in detail. But yes, it's got radiant heated floors, which I can direct heat from both the chicken coop or the shop, which is by turning a few valves, which is nice. And I really like that feature to it. I thought the radiant heating would be the safest type of heat. I mean, think about it. This is a chicken coop filled with a few inches of kindling. So yeah, I thought that's a safe heat. Um, so also it has heat recovery air exchanger. Now there's a whole separate video on this particular system. And I have to say now, since we've used this last winter, I didn't have the siding done, but everything else is done on this chicken coop. This has been working extremely good. I'm really happy about that. So check out my other video I have here. It shows you how to design it, make it, and even download the 3D printed parts for all the vanes and things to keep all the air circulated. But I'm very happy with this one. It has humidity control. In fact, the humidity control, this is what turns on and controls the fans for the heat recovery system. It's set at 65% right now. You can just adjust that in the software. And the fans run almost continuous, I noticed, because it just seems like, you know, it needs to get the humidity down there, and it does occasionally shut off, but I am really impressed at how good the quality of the air is in the chicken coop because of this continuous air exchanging, and yet you don't lose the heat. We had such a cold winter last year. We went almost a full month of sub-zero temperatures. I mean, this cold spell started at 20 some below Fahrenheit. It ended at 19 below Fahrenheit. And we had some of the days got up to a high of -4, and yet the coldest temperature I ever recorded in the chicken coop was 23 degrees above. Even days that were really cold, the temperature would still sort of rise up. So I'm really happy how that system works. Um, it's automatic chicken door. It's on time. Chicken safe, so doors and the door cannot, pinch a chicken going through there. It's got some sensors on there too, and it's also a time door. So time and temperature door. Really, it will shut at the same time every night. But in the morning, if it's like 10 or 20 below, it's not going to open up until much later because it's a combination of time and temperature that actually drives the door opening. So high Kelvin lights. Kelvin is a quality. Okay, lux is a quantity, a lot, but quality of light, that's a Kelvin rating. And I'll explain that because I went with high Kelvin lights because I wanted to mimic the summertime sun. It's what people use for the SID or seasonal affective disorder, all those type of things here too. And so I thought Kelvin lights is probably what I'm going to give it a try. I could not get a lot of research on the exact color lights I want, but I did find a lot of research on what you should not use, like fluorescent and things like that. But I went with high Kelvin lights. I went with metal exterior siding. Now, I could have cheaper, put this together with just wood siding and one buys and painted in contrast colors and all that, and it will look stunning for a few years until I had to rejuvenate it. And I didn't want to really mess with this for many years, and so I put on metal siding for that reason. And we have some raccoon problems occasionally, and I don't want. And raccoons just you cannot climb on the metal siding; it's just too slippery. And I'm kind of happy that I used this. Unfortunately, I bought the metal last year before the prices went crazy, but I did manage to finally finish the metal siding this spring. And the whole thing's solar powered. I run this whole thing on a 100-watt solar panel, photovoltaic panel. Now that's a little underpowered. I probably should have, would have, could have put a 160-watt panel, because in the middle of winter you can get several days of cloudy, overcast weather, and yet the lights are still on, the fan's still running. The door still opens. You don't get the solar pump running because that only runs when it's hot enough to trigger that. But yeah, I had to upgrade my battery just to keep from running out of power. So it is sort of minimum powered. Now this is the summertime. This is where they stay all summer. This is designed for keeping them cool. I can drag this around with my tractor. I have a video on this particular system. The wheels automatically come down and lock in place, and I can just move it around the new grass. And they really like this place for the summertime. But this is not designed for a wintertime home. Um, so the wintertime home, this is what I did. Now this is the end of my shop. This is an already existing building. The siding was getting pretty grungy anyway, so I figured it's a good time to rejuvenate the whole thing. Of course, that postponed the finishing of this because I found some walls I needed to replace that was leaking because of the bad flashing, replacing the shop door and everything. By the time it all came around, winter came before I had my chicken coop completely finished. But now it's finished. I still got some, you can see some landscaping and stuff to do here. But right now it's 97 degrees and humidity seems above that. And we've not had rain here for about a month, it seems, and everything's rock hard. So I'll be waiting on this to get the landscaping done. And right now I'm just like, once I finally got that last gutter in place and downspout, I walked away. It's like, I'm done for a while. It was a little bit of a slog to get this thing done this far. This is going to be the other end of it. Now this is 8 foot. The running area is about 8 foot, and the chicken coop's 8 foot. I have 6 chickens in there. It's about 7 foot high ceiling. So the whole thing, the roof is 16 feet, and that worked out really nice for the metal siding or the metal roofing to come right to the edges all the time. So I got metal roofing, metal sidings, and aluminum soffits. Now the weak link is probably going to be these 2x4s. I just used, these are cedar posts on the end here, cedar post here, but the rest of this is just pine 2x4s. Now they are sort of protected in somewhat. But I just got some tung oil, outside defense oil, it's called something, and I'm going to be applying that to this just to give this a little bit more longevity. I know it's the weak link, and I will be having to mess with this in a few years, but yeah, I'll do that. But I didn't want to mess with the rest of it, just this section. I know the chicken wire is not going to last forever anyway. So now this is the door. I'm really happy how it worked out. I went to our local Restore branch, and I just happened to be there on the right day, and this door was half price. And long story short, I got this door for $10. It was a full screen, 100% aluminum door. And what's really nice about this is a 36-inch wide door. However, the inner panel where all the screen went is 32 inches. Well, 32 inches is exactly the same size of some of this hard wire you can get. So I got this 32-inch wide or tall wire, unraveled it best I possibly can. I was a bit in a hurry last fall, and put it in place. And I had these pieces of aluminum. These are angle iron aluminum, unequal legs, 1 inch by inch and a half, or sorry, 1 inch by 1/2. And I was just able to cut them and use small screws and screw them in place. And there's a little area behind so they don't go through the door or anything. And it turned out really nice to give me a very structural door that's going to be raccoon proof and last many years because it's all aluminum and whatever. So but it turned out really nice on that too. Everything else is all aluminum flashed here too, so I try to make sure that this is going to last a long time. I think my secret on what I found out about metal siding, spend about twice if not thrice as long doing your flashing than what it takes you to get your siding up, your metal exterior. I think the way to think about this is that the metal siding's only job is to protect the flashing. So yeah, there's a lot of flashing work prior to applying the metal on here, but it did turn out really fine. Now this is my radiant floor. This is what I used. This is 8 foot by 8 foot. The slab's anywhere from a foot or so in the corners, if not more. And 4 to 6 inches on the top here too. And I did the same construction, excavate it, compact the soil, crush limestone on top, compacting the limestone. And then on top of that, I leveled it best I could and put on this polystyrene rerod on top of that, which then I zip tied this PEX LPEX. Now PEX LPEX is really what you're supposed to use in the direct burial concrete. That's code for that. And also code, you can see here, I got some PVC pipes. That is also code. You cannot just put the PEX right into the concrete. That's not a strain release and it will wear and break there, I guess. So, but yeah, this is something I had left over from my solar trough project. So great place to use it. And the PEX AL PEX, the AL stands for aluminum. What it is, there's a small aluminum barrier inside this PEX, and it's really designed for these heat loop type of systems. So this is the inside of my chicken coop. This is the roost here. Now these are not full 2x4s. There's research out there that talks about the comfort level on things like that when it comes to chickens, and they are attached in the wall here. And you can't see these attachments. There's a little brace underneath each one of these out here, and they're actually then lagged to the wall here, and they're all rounded off on the tops here too. And I think these are about 2 3/4 or 3 inches, pretty close to those measurements wide. Now I wish I would have rounded the top on these back pieces, and I'll probably do that before next winter, because I didn't think the chickens would roost on these things, but we find sometimes the chickens will roost sideways up here, and that's kind of a sharper corner. So now this is I do have 110 volts here. And like I said, in the wintertime, I will plug in I think it's a 4 gallon heated water bucket just to keep them freezing. We do put that on a tray because that's going to help you keep your humidity down, even though it was never a problem. And of course, we got poop trays in here too. We clean out every now and then. This covers, of course, what this little built construction project here is. That covers the tubing coming from the floor, the PEX. Now, what you don't see, there's another power box way up in the top up here. And that is because I plug an IP camera into it. My wife calls it chicken TV. We can watch it on a computer and phone, whatever, and it shows us. But I use that up there just to make sure all the chickens were in and everything was working fine. The door was shutting and all that type of stuff. But now it's just more of a entertainment channel. But yeah, that's kind of was fun. Now here's the mistake. This is my nesting box, and the mistake was the top recess. This type of construction is fairly easy to do. You just build a perimeter, and then you have a rabbet, and on the inside, and then you can put a piece of plywood up in it. But unfortunately, that gives you this kind of half-inch lip. Okay, and the chickens we found out the chickens love to stand here and watch the outside world go by, and they also poop right there. Because it's got a little recess, it's a little harder to clean out, and I think if I would have redone this, I would have made this completely flat across the top, so it's a little bit easier to clean the crap off. The boxes are all the same size, just a little bit bigger than the one on my chicken tractor. In fact, we found one time we found 3 chickens in one nesting box. They all prefer this on the edge, much darker. Now I thought about painting the inside of these things dark just to give them a little bit more darkness, and that might do it. They still play in here, but this seems like this is the one they lay all the eggs in. So, and again, this is the kindling I talked about. This is why I like the radiant heating. If your whole floor is covered with kindling, make sure you have a safe heating system, and I don't think you can get any safer than a radiant heated floor. So now here is my chicken door. Again, this is computer controlled. I use a Rev Spark motor controller plugged into my Arduino to control this up and down. Now this will close the same time at night, but it opens up at different times during the day because I'll actually look and see how cold it is outside, and if it's like 10 below, it's not going to open up the same time if it's say 35 outside. So it'll open up at different times in the morning. But what you see this little blue arrow pointing to is a little dot here. And what that little black dot is, there's a small recess in there, and there's a cadmium sulfide or CDS photocell in that. And what that does is that on one side, which you don't see on the other side over here, there's another little LED. So what that does, the LED, I mounted that first, saw where it shone the light on spot, and then I mounted the receiver right here. And so when the door is closing, I actually turn on the LED light. I can register exactly how much light's getting to it on the cadmium sulfide photoresistor. And I can tell if the chicken's blocking it or there's nothing in the way there. So if a chicken happens to be standing there when it's closing, it's going to see a chicken is there and stop. And it'll wait a few seconds, and then it'll start again, then look and wait a few seconds until it's all clear. And then I figure it's the best way of keeping the chicken safe. And what you don't see in this picture, I also mounted a mirror down here, at chicken level height there too, and occasionally you'll see a chicken staring in that thing. And I mean, the days get kind of long in the chicken coop, so I thought a mirror might be fun. Now, what you see in these tubes here, this is nothing more than PVC piping tubes I cut in half on my bandsaw. And they cover up wiring. This wiring on this side, of course, goes down to the cadmium sulfide photoresistor. But this wiring on the other side has another purpose, because you can see a little dot right here. I did not get a close-up of this, but this little dot right there is one of those rare earth magnets with a countersink in it, which I just attached to the top of the door. And down here, you might be able to even see it, there's a small little receptacle here, and that's got a reed relay in there. Because I originally tried a mechanical switch. When the door went down, it hit the switch and triggered it. Well, you get some poop in the way or whatever in the way, and something, it just wasn't working all the time as best I could. So I replaced that with a reed relay, and now it's a proximity switch with a magnet. So when the magnet gets close, it will trigger the reed relay to saying, "Uh-oh, the door is down." And I think I'll have it run another half second or so and make sure it completely closes. And that has been working fantastic. I have not a problem. Now my door is not just a piece of wood. It's actually it's got a 1/4 inch plywood on both sides, a piece of foam in the middle, and it's a lot wider because this end of the linear motor here, it's got a pretty good size, coupling on it. So that's why I use it for that. And I figured it'd be nice, cold proof door too, whatever. The trims here are nothing more than cedar, which I've got kind of oiled up, and then I went ahead and waxed them up then too, no problem. I'm not worried about that. The outside of the doors, it's just got some trim on it. In fact, I was able to get it pretty close just by putting up this paneling. It's all metal paneling with the exception of the ceiling in this run and this wall of the run. And I'll probably eventually just put some caulk on here to transition it, but it got pretty close in there, so I'm kind of happy with that. Here's my high Kelvin lights. Now I do list where I got these in the next screen here too, but Kelvin, this is what this little screen is below me here. The sunlight is blue, and way down the bottom, it's more like candlelight. And what we see in the wintertime, people will get treated for seasonal affective disorder by getting the high Kelvin colors. It's better. It actually helps when it comes down to shutting off your melatonin production. Chickens got pineal glands, just like humans do. And so I don't really have the solid research on this, but I know enough about humans and when it comes to how a light affects us to extrapolate the data and guess about chickens. And I don't know, I'm really happy how that worked. In fact, one of my neighbors came over and looked at my system, and he's been raising chickens his whole life, and he says, you got happy chickens here. So I figured, good enough with me. So these are 6,000 Kelvin, which means it's kind of up here in the top here. Not really bright, but very, very bright. I didn't want to just put in an incandescent bulb. I didn't need these things for heating in the chicken coop. They run on 12 volts, and like I said, they're controlled by my Arduino. This is the light I'm using, this ROY FACC 108 LED 6000K. Again, I'm running this on a solid state relay that my Arduino can trigger. I do have an LED lamp in here from 110 volts. I used that during the construction phase. I just left it up there. I don't use it. It's just there in case I need it, whatever. And this is a junction box where I hook both of my lights to. I have a lot of these junction boxes in the chicken coop here to kind of protect things, but it makes it easy to switch and swap them out if I ever have a problem, and also easy to construct. Now, what's different about this? I put this DHT22 sensor. Now, this is a humidity and temperature sensor. This is how I can sense the humidity in the chicken coop. And this whole area here, this is right above where the chickens roost. So I think it's probably going to be a pretty good idea what humidity is in here. And again, this reports right to the Arduino. And whenever I have it set at 65% humidity, it will do relative humidity too, but I'm just looking at right now the humidity. And so if the humidity ever goes over 65%, well, that triggers the fans, both fans on my heat exchange system, and I get an air exchange in the whole chicken coop. I cannot stress how good this system's been working, so I'm not going to mess with it. This is the inside, another junction box up here. Now again, I'm not going into a lot of detail on this air exchange system. I have a whole separate video which I went into great detail on how it's built, even linked to all the parts, internal structures of this thing as well. But I'm surprised that the fans ran almost 24/7 last winter. And yet the air quality was just great in here. You walk in, it's like, hey, this is great. And I know the chickens enjoyed it. And even these days when it was so cold, this would not chill the chicken coop off. It worked great on the heat recovery. So I'll stop saying great, but I really like this system. It's about 14 foot long by the time it goes from one corner of the coop and then exits out the side here. This is the intake and output here too. And occasionally you'll notice this will drip water, because what it's doing, of course, it's sucking cold air in, and you get condensation on the inner tube you don't see here, and it will drain off. So it is all sealed up and waterproof, and sometimes I'll have a dripping off the exit here too. So it's a pretty large, I think this is a 6-inch large diameter, that drain waste vent stuff here as well. But yeah, I'm liking this, and this is what controls the whole thing. This right here, this is my Arduino. Now I had to make a custom shield, but it was really close to the one I used in my greenhouse controller anyway for my solar system out there. So I was able just to tweak a few little pieces here too. But I know you can get some Arduino shields, prototype ones. But for me, it was a simple thing to make just a printed circuit board. Now, what you see here, these heavier wires are these are about 75 feet long, and they come a long way to my photovoltaic system, my panel. And anytime you're shipping DC voltage over distance, don't scrimp on the wires. And this is pretty good size for 100 watts anyway. Multi-strand copper. Of course, that takes them down to these junctions here, right to the Jenison controller. I really like these Jenison controllers. They're wonderful for these smaller systems. And I think if I did remake this, I have a 100-watt photovoltaic panel that powers this whole system here, and that's the lights, fans, and motors, and everything. I probably would put a 160 watt, because these long summer days, long winter days where they're really cloudy all the time, boy, short winter days, it seems like you can kind of use up a lot of power, because even though you might not be producing, you're still running the fans almost 24/7. The lights are still on a 15-hour schedule, so they're on in the morning and off at night. So yeah, you can run a battery down. In fact, I used to use this interstate battery here. It just didn't have the capacity I needed. So, and these are the solid state relays. Now these are DC-DC relays. This is how I control the pump, the lights, and the fans. The red lines, it's just nothing more than distributing the voltage everywhere. And a small signal voltage from the Arduino will turn that DC relay on. Works great. Also in this picture, this 8.8 up here, that's the voltage I'm actually putting to the Mega, the Arduino Mega. I like these buck converters. They're simple, easy, and they give you a real consistent output. I got into trouble using some of these LM08 type of linear voltage supply systems, because I started using almost to their capacity, and they started heating up. And anytime that happens, you start getting fluctuation in voltages. And since I'm using the analog system, you get some funny numbers in because your voltage would not be consistent. So yeah, I went to this system here too. Also, what you see here, this is a small another one of these little small radio frequency controllers, because I have another key fob. I can just override the doors and close and open just like a garage door with this remote control system here. I put another voltage system here too. I just push that red button. It tells me what the battery voltage is. I can do the same thing over here because it's got two sets of switches on here. I can switch to the input voltage versus the output voltage, but this worked really fine. The covers are off of these right now. They're usually covered up. That's just your voltage from your battery, 12 volt, and your ground, of course, all grounds together. I'm using a mini Rev Spark motor controller for the door actuator, works perfectly fine. And of course, you're going to have a lot of connectors. And I got into a habit of using these little bus bars to make sure things are labeled so you know what you're doing. Because you can see it gets kind of like a rat's nest pretty quickly here too. And also up here, here is a real-time clock module. This is what keeps the clock ticking, so to speak. And I know what time it is, and these things are, been pretty much rock solid for a long time. I do have a LCD controller up here, which how I design my software anymore is I have one button that's going to kind of control button. In this case, it's the green button, and every time I push the green button, it will advance the screen. And that screen, and then the next screen may be delta up or delta down, or the temperature making the pump turn on or whatever. So basically I can go through the screens and the other two buttons and I can adjust the variables on each screen. That way I can put a lot of information on one LCD screen by going through several different screens. And that's worked really well. And that's kind of been my my MO for how I'm designing these Arduino projects for a few years now. Of course, I have a cutoff switch here and it's fuse protected as well, so I can flip the whole thing off there. Um, but yeah, I like it kind of spread out because it does get kind of busy. In fact, it gets even busier down the bottom here. These are the two lines coming in from my solar collector. Now I'm running a food grade antifreeze through this. And I run PEX on the slab inside the shop here, but everything going outside, that's all copper with the insulation on it. And there's a lot. I have lots of sensors that I can sense the input and the output of the chicken coop, so I can compare the sensors wherever the temperature is going to be and then turn on the motor or whatever. Here's the little solar motor I used. I didn't list this one, but just under a DC solar motor. I originally had a peristaltic pump, I should say, or solar pump. And that peristaltic pump, first off, you had to like bolt it down because it was vibrating across, but it was so noisy electronically that it would freeze up the Arduino and I could not use it. This solar pump, boy, you almost got to listen really hard until it's on, and it does just a marvelous job. Happy how well this system works. And too, I did have clear tubing here. I probably will have to exchange my medium every year or so, but because this is not an oxygen barrier. But I needed this. I just used this because it was easy to make that corner. Now these valves you see here, okay, this is the valve in the middle here. That's when you originally charge the whole system. You can get all the air bubbles out, and there's a drain here to hook up to it, another drain to purge the whole system. But those are just used when you're originally charging the system. Now this valve up here and this valve down here, I can control then where the hot fluid's going to go to. I can make it go all the way to the chicken coop, or I can go up to a radiator, or a combination of both how I want it. So that's worked really well. Also, I have a gauge here that tells me what's a PSI on my line, and those are good to see for me anyway. But right next to that, right here, that is a pressure transducer, and I would really recommend putting those things on the system because I'm running about 22, I don't know. This one here probably is around 28 PSI. I put that on there to one, it increases the pressure boiling point a little bit, but I don't really care about that because I'm not going to use this in the summertime and these temperatures are not going to get that high in theory. But what's nice about the pressure transducer is that the computer then can monitor the pressure. And if it ever falls, say within, if it falls down below 10 PSI, it's going to tell the computer saying, hey, we got a leak here someplace, shut things down, because this solar pump down here, it's in the instructions, do not run this pump dry. So really that's more basically to save the system. And if it does sense that the PSI goes down so low, I can have this thing like flash the screen or whatever, somehow notify me that we have a leak here. I'll probably see a big puddle on the floor unless it's under the slab or something. I don't know. And also, here's my little remote. That's the remote here too. And this is also the battery I'm using now. I got rid of that interstate one. It wasn't the capacity. And I got this Weiss 12 volt deep cycle. This thing weighs twice what the battery weighed, I think, of the original one. Um, but boy, this is a great battery. I'm really happy about that. And also, just FYI, in these Jenison solar charge controllers, there's a small little jumper inside here, and it's all covered on the instructions. That if you're using, say, a sealed battery versus a flooded battery, you have to kind of change that little setting here too. But I did actually contact tech support because I had some suspicions about this battery here. And even though it looks like a sealed battery, I sent all the specs to the tech support, and they wrote back to me and saying, yes, based on what you have here, we would use this under the flooded settings, and that's how high it charges, and there's a couple of peculiarities in it too. So, but anyway, flooded settings then too for that particular battery. Of course, you have to have an overflow pressure tank here too, just in case, because you're going to get changes in pressure because, well, temperature proportional to pressure and all that. So. Um, I don't think there's anything else on this board here. Yeah, it's kind of a rat's nest of things, but oh yeah, this up here, this is the box I'm using here. Now inside that box, I didn't get a close-up of it, but there's another solid-state relay in this box. And this box actually is a solid-state relay of DC-controlled AC, okay? And in fact, what you can see here, I plug this AC plug into it, and that goes to my radiator fan. Above this whole system, I just built up some aluminum, weld it together, and these are like I can drop this radiator right into it, and I put a little welded a little in the bottom stops here, so the radiator just falls into it and stops. And what you can't see behind there is a pretty good sized radial fan, 110 volts, that really puts a lot of air out. And so when I'm directing my fluid, my heated solution, to the radiator, it just blows through there, and I am really happy how well it heats up that part of the shop. I used to think of that side as kind of the cold side because it's not where my wood burning stove is at. It's on the other side of the shop, and now this thing does an excellent job with the other heaters in there too. So this particular heater did come, or radiator did come, what's called AN, or Army Navy fittings, but there's a lot of interfaces out there to take you right to the National Pipes red fittings. So that's what I did here. That's how I connected up my PEX line to it. Um, yeah, I like how that's been working. So again, that's the whole system. I just plugged that particular box into the wall, and then use that relay to turn the fan off and on depending on the temperatures I want it to run at. So yeah, it's a couple extra wires pictured here. It's my USB cable that just sort of have in hand there too. But um, I'm I'm happy how well it works. So this is how I heat my water. Now this has got the cover on it. Okay, this particular water heater started life as a solar roof water heater that actually runs this solution through a heat exchanger in my water tank, or pre-water tank. Well, I rebuilt that whole system, and that's why I'm using that photovoltaic trough, or that I should say Fresno reflecting trough for my pre-water heating. But I had these lovely, wonderful systems here, so I went ahead and used one of these things um, for heating the whole solution system. Now this is it open. I built this cover. You can see this cover on the outside here. This cover is what you're looking at is aluminum flashing. It was 20. I got some 24-inch wide stuff, so that covered the whole thing. But I built this aluminum frame. I had this aluminum lightweight 1/8 inch by 1.5 angle iron. So I just welded up this frame. It's going to last a long time. And what you're seeing here is on one side of it is I glued down some of that aluminum flashing, and the other side of the foam. This is nothing more than a foam board I have inside here. I went ahead and used some glue, spray on glue, and glued up some of this aluminized mylar, and the whole thing's then caulked in place on the aluminum frame, and it's all hinged in to the bottom braces here with these stainless steel hinges. And so I can, you can see how well it reflects the summer heat, and it does the same thing in the wintertime, of course, too. But there's a couple other advantages here. I mean, this polycarbonate's wonderful stuff, but it's also easy to scratch, will get brittle, and punch some holes in it and give you problems. So we have last winter when we had an ice storm predicted, I went ahead and just closed it up at night. When you open it up the next morning, you don't have to worry about getting the ice off there, scratching anything. It just goes a long way to help protect it and magnifies its effectiveness. Now, I don't use this tube in the wintertime. Actually, I set up a couple cinder blocks out there with some 2x4s. I'm still kind of working on a little bit more elegant solution, but that definitely worked. Now, how I mounted this to the shop, um, I do a lot. This is nothing more than 2x4s, and I have a small little brake, a 36-inch brake, which I can bend aluminum flashing. Um, so what I do, I just sort of encapsulate these 2x4s in this aluminum, slip it up under the siding here too, and lag them to the wall studs of the shop then too. There's end caps on it to protect it, and then I can go ahead and just lag my frame to those 2x4s. Now, this is another reason why I really like welding aluminum. What this is 1.5 inch by 1.5 inch by 1/4 inch thick aluminum angle iron. Really tough stuff, 6061 uh, grade, and it welds up great. And unlike steel, steel would be great too, but then I have to worry about finishing the steel, keep it from rusting, protect it. The beauty about aluminum, I can just weld it up, wire brush it off. You can see I didn't wire brush it off with near enough down here. Put it in place, set it, and forget it. So yeah, I really like welding for exterior things in aluminum. Um, Makes it so much easier. But that's it's all folded up on here too. You can see my wires up here. I do plan on putting some aluminum mylar covering just to kind of give this insulation a little bit better longevity here too. So, but I have been happy how well this has turned out. The chickens, like I said, my neighbor said you have happy chickens, so I'm just like I'm great, you know. Um, I wanted to get this together, set it, don't have to worry about it for many, many, many years. Hopefully that's the way it's going to work. I can see the future though. I can see this end over here, as I talked about, will needing to be upgraded, replaced, or something. But that's better than having to mess with the whole thing. There's not that much wood out here on the other side there as well. So, but anyway, I am glad to be done with this project. If this helps you on your chicken coop, great. I mean, for me, this whole last year was year of the chicken because that's when I was making this chicken coop and as well as the chicken tractor. So, anyway, hope this helps. If you want the code or plastic or the PCB artwork, contact me. I can upload it to um, GitHub, but be warned, my software is not finished. Although I love that phrase, software is never finished, just given up on. But it's very functional at this time. So, anyway, hope this helps.